Record. Hello, everybody. So last lecture, we just had a kind of a little bit of a gap between the week 1 and week 2 stuff where we were covering a simple state machine setup that goes kind of along with this experiment that as a text walkthrough. And for this week, we will be digging further into state machines. I'll just talk about these assignments real quick, and then we'll actually get into some content for working with the state machine that we're going to provide you for this assignment. So this lecture here, Building Better State Machines, goes over just some more general things about state machines. What are they? Why are we using them? Stuff like that. And then it takes a look at a couple of common state machine models. There's a lot of different ways state machines could be set up and things like that. So it's going to kind of analyze the different types of state machines and things like that. And then down here is probably a link to one of my favorite design pattern books ever, or programming books in general for games. It's called Game Programming Patterns. And specifically, we're taking a look at the chapter state, but this link actually brings you to this website where the entire book is hosted on this website, free for you to use outside of O'Reilly and stuff like that. A lot of the code examples will be written in C# style script and stuff, but shouldn't be too much of a jump from converting this from simple C# script to Blueprint. The biggest part is understanding how the code's running and set up and stuff like that, not focusing on the syntax itself. But this is a great actual explanation of those different things, even goes over enums and switches, which we saw from last lecture. We were using those and stuff like that. So highly recommend you bookmark this website and take a look at some of the other chapters or other design patterns as well whenever you have some free time. Outside of that, there's this discussion post, feature analysis for state machines. And I believe I kind of talked about this a bit last time, where you're going to analyze a game you're currently playing and try and break down one of the character states that you can think of. Like, what is that character? What kind of states do you think that character would have, and what kind of exit conditions to go to the other states and things would there be? I just want to reiterate, there is no correct or incorrect answer here. Just try to do your best. This is your first time even knowing about state machines, and ultimately there isn't ever a right or wrong answer. It's all just up to the designer or the person who's making that system which states they want to include. All right, so back to our general overview. This assignment. So assignment, we're going to get an NPC working with the state machine. So just like how we were kind of introducing the navigation system, we got an NPC patrolling around. We're going to take a look at how we could switch that up with actually using a state machine to control its different states. The assignment itself, not a lot of instructions on FSO, but linked to the actual assignment page. We will be providing you with a state machine, so you'll get some experience working with other people's code that you don't necessarily write yourself or fully understand. You just need to know how to use that code itself. The actual project or package that you'll be working from is this 4_state machine assets held in this assignments repository, which is just where all the assignments are on the Google Drive. So we'll go ahead and download this, and we'll kind of explore it and take a look at it and see how things are working and add our own state to it today. And where is download? Probably behind these meeting controls. Yes, it is. So we'll download that. And let's talk about the experiment itself first before we dig in there. This one does have you kind of check out the different things, describes a little bit about how things are set up. and then goes into adding another state specifically for pausing or basically stunning our enemy, puts it into a paused mode. So you'll be adding a brand new state for pause, and that walks you through that. And then as we can see, this is another screenshot submission. There will be 2 agents in the level. One of the agents will be just running through the state machine and patrolling like normal. The other one will have pressed a button to change it to the pause state and turn it gray. So let's take a look at the state machine provided and see what comes with that. So we'll have this just zip here. What we're going to do is actually extract this zip. We can't open it straight from the zip folder because it's compressed right now. I'm going to just find a better place to put this other than downloads. It's generally not a good idea to keep working projects inside your downloads folder. So I'm going to just go to my C drive. I have a folder that I've called classes where I'm putting some class material stuff. For SCD3, I have a few different projects in here already. I'll just create a new folder for this assignment. And we'll call it NPC W state machine. So NPC with state machine. And we can grab this stuff from the zipped folder, project file, content and config, copy that over here. And whenever you copy from a zipped folder into a just general folder on your computer, that's how you can unzip. You can also use the right click and extract all method or 7-zip extract here. It's doing the same thing, just creating a new folder for you. All right, we have it extracted in just a nice place to put that assignment. We'll open this assignment up. Waiting on Unreal. All right. So we've got some things in here. If we just press play immediately, and let me just get rid of those notifications. If we press play, we see the agents are just kind of pathing immediately. They're actually using the state machine. We've set up 2 states for you already. There's a patrol state and a idle state. We see that the agent is actually changing color slightly. When it goes to the idle state, it goes to a darker green. And when it's in the patrol state, it's just normal bright green. And it's actually pausing at each one of the little states here, or each one of the little target points. So we stop playing, and let's explore kind of how this is set up. I'm going to show all the content here. We have this GDB state machine folder and the mannequin for just the visual assets and stuff. This state machine folder has AC base state, state idle, state patrol, state machine, a nav agent, the nav points, which we saw how to set those up in a previous experiment. A couple of interfaces, one for the machine, one for the agent itself, and of course the level. Let's open up our nav agent itself and take a look at that. I'm going to just click edit. You could also just double click that to hop over to the blueprint. And in here, there's a few different events. Easiest way to explore a new blueprint that you didn't necessarily write, rather than having to search around the event graph like this, highly recommend you're checking out the My Blueprint tab. You can see everything this will have and can easily navigate and jump to where you want. So for begin play, It's got this not really connected, so that's pretty much commented out and not running. Begin play, what it's first doing is telling AC state machine to set an initial state, and it's setting it to patrol. So we see over in the components that it does have a state machine, as well as each individual state added to it. So our state machine will be referencing these individual states and just running one at a time. So begin play, straightforward there. Our actor begin overlap should look similar to the last one you had done. It's just checking when it hits a target point, increment the index, and then it's rather than telling it to find destination immediately, it's just saying change a state to idle this time. So we'll explore those states in a moment. I just want to finish exploring the nav agent itself. We have the next destination, which is finding a destination. If we open that up and double click it, it's just telling our character to move to its certain point. All right. And under interfaces, we see it does have an interface for this next destination. We see that that interface is showing up on here as well as this one. That means that this nav agent can be sent messages, and going through that interface allows it to be called outside of this class without knowing the specific type. In addition to that next destination, we have color override, which is just a simple helper function to set the actual color of our character. So that is pretty much it for the nav agent itself. Let's explore each one of the states individually, and then we'll, well, let's start out with the state machine. If you want to open this component, if we just double click, it's going to bring you to the viewport, which isn't too helpful. I want to know what this component does, how it's set up and stuff. You can actually right click and go to edit right here rather than jumping all the way to the asset browser and finding it there. And just like we did with the nav agent, I'm going to look at the My Blueprint stuff for all of its things that it has. We do see it has a couple of different variables, or they're considered components in here. There's a current state, a next state, initial state, a couple of bools to determine whether it's going to be changing the state right now, and a map that's set up to hold all of the individual states. So that's pairing a base state with the actual, like this base state is actually a class type, and it's pairing it with a specific value. So that's the specific component it'll be selecting. So there's a few different things in here. Let's start with a begin play. It's always a good spot to do this. You see it's just calling this add states message, sending it to itself. A little bit weird. Could just call it directly, but let's check out what that function's doing. Let's focus on that. Add states. Asks for the actor component owner. Now, since it is an actor component, it itself is not an actor. It doesn't have all of the states that has it. But after we add it to a specific actor or agent or pawn character, things like that, the owner would be the agent itself. So we're asking for, give me the nav agent. Then it's searching through the components list for anything that derives from base state. So that's going to give us any states that we've added as components here. So it's going to give us patrol and idle. Returns that as an array. For each one of those individual references right here, it's going to add that to a map, specifying what class type it is. This gives us that quick drop down option that we saw over in here. When we call just change state, we're able to just select from what type of states there are. All right. And not sure why that's all commented out. I think I was supposed to delete that, but whatever. So we have that begin play, just sets up that state map or all states map. And we'll move into tick. Tick runs every single frame. So every frame, immediately it's going to check, should it basically exit this state? And see this being used elsewhere. Basically, anytime we tell it to change a state, it doesn't immediately swap out the state. It finishes that current frame. Then on the next frame, it'll say, hey, we should exit this state. Runs up here, lets us know that it hasn't exited yet, tells our current state to exit, sets our current state to whatever our next state was set to, and enters that new state. If it's false, meaning it's just normal and we haven't told it to change states last frame, it's going to run in here, seeing if it should enter. That logic seems a little bit weird. But if we should enter it and haven't called enter on it already, go ahead and call that enter again. If it's false, we're calling something named execute on the individual state. So the states themselves have a few different functions. There's enter, exit, and execute that they're all getting called on and stuff. Enter, the best way to think about that is like, that's kind of like a begin play. It gets run once when it first enters that state. Exit, well, that's pretty much the opposite of that. When it's leaving that state, if there's anything you needed to wrap up or, for example, like a pause state, when you exit a pause state, you could probably enable movement again. That'd probably be a good thing to do. And when you first enter it, disable that movement, stuff like that. Then we also have this third one called execute. If your state itself has anything that you need to like update per frame or anything like that and have run constantly, you can throw that in execute. We'll see that a bit more once we explore the individual states. But let's finish the state machine first. There's an event to set the initial state, grabs the actual reference to it from the map, and initialize it. Initialize just sets our current state to true, or sets our current state to whatever that initial state was, and tells it to call enter on that next frame. We have the change state, which checks our map to see if it does have this state we selected from the dropdown in there. If it's currently in the same state, it shoots out a quick print message saying, hey, we're already in this state, probably shouldn't be telling us to change to this state if we're already in it. If it's false, then we see it's grabbing that and just going through, tells it to exit our current state, prints a message. So there's a lot of different print strings in here set up and are running. Let's preview that again, but this time I want to make sure my output log is showing while this is running. So as we're playing, we can actually see the individual agents when they're changing state, what state they're changing to, stuff like that. So highly recommend you have your output log open while you are running so you can kind of see the pattern of how things are switching up. All right. So other than change state, we already looked at add states and everything. So that's all the events here. Then the interfaces, we have is in state. Is in state, we'll check out that. We'll see these other ones are green. That means they don't have any returns. This one's showing up blue, and it does have an output that it has to do, so it's got to be in its own graph, can't just be in the event. Events can't have any outputs. So just checks, well, is that new state the same class as our current state? Lets us know, returns a bool, whether that's true or false. Then we have a macro setup for check map key. Check map key we saw used a little bit earlier. It's basically just trying to search this map, trying to find it, and we've added a quick error thing saying, hey, you might have forgotten to add that state to the object you're telling it to switch a state to. All right. So that's the state machine in general. Let's see how one of these states itself is set up. Let's explore the patrol one, since that's what state it does first. Let's edit that. We see in here, it's a very simple thing, just focuses on what it needs to do. When we enter this state, we're getting a reference to our owner, which is essentially our nav agent, shooting it that message to change color, and shooting a message for next destination. Just a reminder that next destination, all that does, tells it to find destination, and basically is just saying move to our current nav point. So patrol, very simple, move to the current nav point, set your color to bright green. Perfect. Then let's check out the other state, our idle state. Edit that. In the event graph, we have two different things here. We have enter, and that's getting the owner, getting the controller, or getting the AI controller and telling it to stop when it enters this state. We're also changing the color to a darker green. And then very last thing we're doing is setting a variable we have called time tick. And what this is going to do is, since this idle state, we're just going to be running basically a quick little timer that we've set up ourselves right here, so that it pauses for a couple of seconds and then switches back to patrol. We also see it's got an event, run main behavior. Run main behavior is just like the execute we saw earlier. Let's see, our state machine was calling that. State machine, event graph on tick. Tick, it's shooting this call execute to the current state. As far as the states themselves, base state has this execute. And what it's doing is it's binding an event to the execute call. And it's called, the event it's going to run is called run main behavior. All right. So basically that run main behavior will be running anytime that state is sent the message called call execute. A little bit of a roundabout way to just get it to call a function, but gets the job done. So idle, think of the run main behavior just like execute. Still running whatever the parent, which our parent of this state is just base state. Then what it's doing, it's getting how the amount of time in seconds since the world was brought up to play. It's then subtracting that from our time tick, which time tick got set to the amount of time right at the beginning. So when we enter this, we're basically setting what time this was entered. And then as it's running, every frame, this time seconds is going to keep increasing. We're subtracting our amount of time. Once 2 seconds have elapsed, or that subtraction is greater than 2, we're making sure to change the state back to patrol. All right. So that's how all of this kind of is working and how we get the desired behavior where they'll run to a point, they hit that point, that triggers their change state to idle. Once they're waited there for 2 seconds, we see it just continue on, and so on and so on. So let's see if we wanted to add another state to this and trigger that off of a key press or something. Well, what we'll do is we'll set up a simple character in here and get it just moving around, and then we'll have it button press, tell our agents to follow that character. So we'll go ahead and create a blueprint class. We'll be creating a character. We'll call this, well, rather than creating our own character, I'm gonna just do this a little bit faster. I don't need that anymore. I'm gonna just import one of the template characters. Gonna go to the add new, add feature content pack. We'll go from blueprint feature. Let's add, we'll go with the top-down character. Yeah. Add that top-down package in here. So it comes in with this top-down character itself as well as the controller. I'm going to drop that into our level and tell our game that we want to control it. So we have top-down character over here. Going to go and find its controller, or player, auto-possess player. Yes, player 0 will auto-possess this one, so we're controlling that. I also want to make sure that our game itself is running with this top-down controller. This allows it to tell it to move and stuff like that. So we want this controller running. All right, let's go to the world settings, and we'll just switch it up from using just the general game mode that Unreal provided to use our top-down game mode so we can start controlling that character. If we press play, it gives us a character that we're able to just click around and move. Cool. Saves us a little bit of time rather than setting that all up ourselves. All right. So let's get into adding a new state for our NPCs that we've got. So for the GDV state machine, I'm going to add that right in here since all of the stuff that we'll be working with is right here for quick reference. I'm going to create a child of our base state and rename it. We'll call it AC, and we'll call it a follow. So AC, going off the same naming convention, we'll add state underscore and then the actual state functionality. All right, first thing I want to do before I worry about getting it to actually follow, I want to make sure that I can change to this state off of a key press. And a way that we can see quickly how if this state is actually being entered other than just scouring the output log, if we take a look at our patrol, one of the first things it's doing when we enter it changes color. So it shoots a message to our owner to override the color. So our follow state will do that same thing. We don't need begin, play, or tick. I'm going to be using those overriding the functions or events from our base state. So we'll get override. We have an enter, exit, and that run main behavior. When we enter this state, we'll get our owner and shoot a message to change its color. Get owner, color override. New color. Do you have a preference of a color for when it's following?
Let's go with a nice blue.
All right, let's go a little bit purplish. Oh, that's very purple. It's going for like a royal blue. That look good?
That looks great. Let's go with
Awesome.
that.
All right. Cool. So when it enters this state, it should change to that color. Let's go ahead and add some code to tell it to change this state. Now, I need a way to process input and have that input somehow tell this nav agent's state machine to change state. If we look at the event right here, we see that how it's setting the initial state, and here's an example of change state. We need that state machine reference telling it to change state to that. So what I'm going to set up is a helper function that it can be called outside of this class. Since we aren't actually controlling this character, it won't be able to process any input events or anything like that. So we'll need some sort of thing to hold a reference to that. One of the ways we can set that up is using our level blueprint. Our level blueprint and already has some stuff set up for us. Cool. So when we begin play, it actually creates a quick array of the agents we've placed in the level. And when we press right, it'll cycle through the agents and stuff like that. But so we are actually selecting an individual agent. We see it even tells us when one is selected. If we are looking at our output log and press play, I'm clicking game to give it input. If we press right, and I'm going to pause it so it doesn't keep printing like crazy. We see I pressed right once, it selected agent 1. Agent 1 selected. The agent it's actually named is nav agent 2. So it selected that nav agent 2 from our scene. So we have that selection already kind of in there. The other thing we need to add is a way to call a function from that. Well, we need a function to call before we can call that function. So on our nav agent, I'm going to add a quick function here, or a custom event. And just to make sure our level experiment, it is holding this array. That type is directly nav agent object references. So we're able to call any functions directly from our nav agent script. We'll create a custom event. And we'll call this set follow. Or let's just rename that again. Sorry, eventually we'll be making it toggle the follow on and off. We'll start out with just getting it to go to follow the follow state and then move from there. Proper name for it would be more toggle follow though. So toggle follow, we see right here is an example of how we can change the state. So from our state machine, grab a quick reference to that component. We'll tell it to change the state. Which state do we want it to be? Let's go for our follow state. All right. And our level experiment will be the one doing the input processing. So we already have that right one set up for you to be able to select and cycle through them. But we'll go ahead and add a keyboard event. Let's say when I press F for follow. Keyboard or key F. And of course, input. Shoot, I can't remember where they store those. Oh. Here we go. There's some input events, mouse values. There's the direct keys. And I said F. There's a lot of things with F in it. Just the F button being pressed. All right, when we press this F button, we'll tell whatever our current agent from this array indexed into, get the array, get a specific one from it. The one we'll be getting be based off which one we have selected. And we're given a direct reference to that agent. We'll tell it to toggle follow. All right. So when we press F, should call toggle follow. We press play, and I press F. Whoop, we're getting a message right here. If we stop playing, make sure you add the state. So it was doing just the normal printing, and then as soon as I pressed F, we got this message right here. Make sure you add the state. Well, we created this state and set it up and everything. One thing we didn't do was tell our nav agent that it has this state that it can switch to. So we do have to add that to the actual agent itself. And that is follow AC state follow. Now that we've added it there, and we press play, click the game to give it input, press F. Whoops, wait till they're finished there. If I press F, it is actually changing blue. All right. If I were to press the right button to select the other agent, I'll wait till he's off of that nav point, press F. We see it changed blue, but it was still moving to that other thing. We need to change how it's moving and actually get it following the character instead of just continuing on its previous path. All right. So we have to add some more things to this follow. We saw it actually was calling this and entering. We need a way for it to go to our player's position. Well, as we see, the way the state itself kind of talks to our agent itself or calls functionality from it, almost everything for the states when it's telling it to telling the owner to do things, it's going through an interface for the nav agent. So we'll open that interface up. I could even just double click one of these to open it up. Right now it's just changing color, telling it to move to its current location. Let's add one for go to players location. All right. So now that we've added this interface function here, our actual agent itself that implements that interface will need to implement this function and tell it what it should do when it receives a message to go to the player's location. We're going to need to do a couple of things. We need to know, what is the player? We need a reference to that to figure out where that is in order to be able to tell it to move to or anything like that. Find destination. You see it is doing the simple move to, just getting the controller, and the location we're moving to is what we've set up in our nav points array. So there's a few different ways we could set this up. We could add another variable here, just like we have our nav points for player ref. Make it public. Make sure to change the type to, let's just do a basic actor. We don't need any specific player functionality from it. We just need to know its location. And with that public or instance editable with this IOpen, in our level then, we're able to assign that with in our details panel per instance. We can actually select it from one of the objects. Well, we have our top-down character as our player. Let's look for top-down character. So this one's got it assigned, and this one we'll go ahead and assign it as well. And this is kind of going along that same method of how we set up our nav points. We're able to change those per individual nav agent as well. And we now have a reference to that that's set in our editor. Okay, back in our event graph, we have this reference filled out now. Should be able to get its location. And rather than even doing get location, if we look at the simple move to, there's two different options. There's a move to an actor or move to a specific location. Let's just go to move to an actor and set the goal to our player reference. Got to make sure to ask our character here for its controller. All right. So go to player's location, all set up there. Our follow, then rather than just doing the color override, let's shoot it a message to go to the player's location. All right. Back here, if we're playing now, and I move kind of over here, press F, our character started running towards us, but we notice a problem. As soon as it hits this nav point here, which is currently invisible, I'm going to go ahead and make sure that those are visible in game. Just go to the sphere and not hidden in game, just so it doesn't look like it's hitting anything invisible. Oh, and it is still hidden in game. Why is this one different then? Hidden. Oh, the actor itself was hidden in game as well. There we go. We see as soon as it's hitting that, it's triggering it to go into that pause state and continue on. If I press F, it's trying to get to us, but hits that and stops. So there's a few different things we can change about this. We see one problem is that it's getting stuck right now and it's not actually continuing on like pathing like normal. That is my fault. On the nav agent itself, there's this cylinder selection. That should not be there for right now. That'll be for a future assignment. You can go ahead and get rid of that so that it just has the capsule collision and stuff. The next assignment, after for week 3, we'll actually be dealing with that. All right, so now it's just got the capsules and looks a bit cleaner. If we were like over here and press F, it went to our actor, but it's not really following us. Even though it's still in that follow state, it's still blue. It only did it as soon as it entered that state. And that's how we set it up. Our state follow just says as soon as we enter this state, go to that player's location. Well, it's going to move to that specific location as soon as you call enter, but it doesn't update our player's location. So here's where the other function can come in handy. If we override the run main behavior, think of this like tick. If you have something going on that you want to update location, we're going to be every frame now copying these two. Don't need to set the color again. The color's already set once. That's good. But we'll actually continuously tell it to try and go to the player's location, since that location changes per frame. Let's see if that fixed our actual chasing issue. So I press F and it did not. It went to location once and stopped. So state follow, run main behavior. Let's make sure that this is running. So we'll have that up, press play, get over here, press F. Run main behavior is not being called. Cool. So we have.
So actually, Justin, the get AI controller, I couldn't get this to work unless I gave it fed in a reference to itself, even though it's using self.
Right. I keep forgetting about that. I did the same thing last month too. We're actually getting an error probably in here for that. But so our inside our state follow, no, not the follow state, the agent itself, where we write the go to player. Go to player's location, focus that. Get controller, I want to get the actual AI controller. And self should already be there, but we'll get the AI controller and might need to switch it from move to actor. I don't know if it's hitting the goal and considering it complete. Get AI controller. Controlled actor is self. So we may need to switch this up to the other one and just get the player's position rather than move to actor. But we'll see. Press F, just hits us once. Now, so something else is going on where this is not actually being called constantly. Let's try this. Nav agent should be the one that we have selected by default. Press F, does get called, but only gets called that once. So something else is going on with our state follow not running the main behavior like this. And let's see what our state machine's doing then. So our state machine should be calling this execute and execute itself. Let's just add a breakpoint. Play. We do see it's hitting that. Let's step into that. Run main behavior. It's nothing in the base state. Run main behavior, nothing in the base state, nothing in the base state. Here we go. We're in the idle state now. And it's running the main behavior here, doing that one. So we need to check this in our state follow. I want to see when this runs. I'm going to stop debugging there, add a breakpoint here, see what's going on. Don't. It's weird. It should be calling this from what I can see, but for whatever reason not. Let me compile and save, make sure that's finished. And I have a breakpoint somewhere that I didn't want, state machine. Remove this breakpoint. Oh, can you hear me now? Oh, yeah, sorry about that. So we just have this breakpoint set up on the run main behavior for our follow state and see if that's ever being called. So we play. If I press F, it is not hitting that breakpoint. Something weird is going on there while it is in this follow state. I'm going to do Shift F1 so I can move my mouse out here. In our state machine, I'm going to select the one from agent. Should be sending that message. Is that it? I forgot to, well, let's add a breakpoint.
I needed to add the parent call here for parent enter state in order to get him to keep chasing. I have basically the same setup as you, and I just tested that, and that seems to be the difference for me.
Okay, that makes a lot more sense. So in the other states, when we were entering each one, it's still called the parent enter. Let's see what that base enter does. That's where it's setting up the binding to call that run main behavior event. That's okay.
It took me a long time to find it too. I was like, why isn't that happening? I was like, oh.
That's poopy. So since we are overriding it, we just never found the execute to call this run main behavior. We'll also make sure it still runs that parent function. Okay. Darn it. Compile, save, and should be good to go now. There's still some issues with it that we'll fix in a moment, but now it should be following me. See one of those issues? It hit this invisible nav point over here and just got out of that follow state. There's some additional things we can actually do to prevent it from changing states when we don't want it to. Right now, our nav agent in the event graph for when it hits something or begins overlapping, we are just immediately saying if it hits one of the target points, change which one you're going to and then move to that next target point. Well, I want to make sure that this only runs if it's in the patrol state. I don't necessarily want it running any of this code if it's trying to chase our player or follow our player. So our state machine itself has this function to ask if it's in a certain state. So we'll ask it, is it in the patrol state? And if it hits target point, so we'll combine these bools using an AND Boolean operation. So both of these have to be true before it runs all that stuff. Otherwise, if it hits one of the target points or if it overlaps something that isn't a target point, we'd just do nothing. We'll just not connect that to anything. So now, if I wait till they're finished with those, get it chasing, let it run over those points, still chases us. Okay. And our characters are the same speed right now, so would be almost impossible to get away from it. All right. Cool. file save. The other thing I want to do, I want to be able to press a button and have it go back to like the patrol state or something rather than just continuously follow. We right now are in our level, which I have a lot open. I'm going to close out of some of this stuff. And our level, we're done with the individual states. We'll leave our nav agent and our level open. F, we're telling it to toggle following of the current agent. Toggle follow immediately just sets it to the follow state. I want to add a little bit of a toggle here. If it already is in the follow state, I wouldn't tell it to go to the follow state. I would switch it back to patrol if we tell it to toggle. So just like we saw how we can, I'll just put that right there and grab another reference to it so we don't have them all stacked. We'll ask it, is it in a state? If it's currently in the follow state, and we tell it to toggle this following, when that's true, we'd want to change it out of follow. If it's not in the follow state, we will tell it to go to the follow state. But as I mentioned, if it's already in the follow state, let's just change it to, let's go back to just patrol. All right, so now our toggle will actually toggle. All right, press F, it's in the toggle state right now. If I press F again, it goes back to patrol. Press F again, we're able to switch it back and forth. Chase, not chase, chase, not chase. Cool. Any questions about any of that stuff we went over today?
Nope, I don't have any questions.
All right. Cool. So that pretty much wraps it up. This document and the actual assignment will walk you through how to add a pause state as well. The pause state, rather than just returning to a normal patrol state, does a little bit more and tracks what the previous state it was in before it switches back. But pause state looks like we're adding another variable to track what its previous state was and go back to its previous state rather than just always going to patrol. Cool. So this assignment not due till Sunday, so plenty of time to work on that. This is the last lecture of the week. I do want to point out that daylight savings time is Sunday, and it is springtime, so we will be moving the clocks forward. You will be losing an hour on Sunday. Make sure to take that into account, especially with that deadline. So don't forget to change your clocks. Most phones will update automatically and stuff like that, but I wanted to make sure you guys were aware of that. Alrighty, that pretty much wraps it up for this week. Were there any questions in general about any of the content for this week and stuff?
I have a question, but as everybody know, as a reminder, there is a discussion post due tomorrow.
Yes, the discussion post to basically doing that breakdown state. But yes, thank you for that. So that is due tomorrow, and then our reply to another person's post is due the day after. Alrighty. Thanks for joining, and I will see you again next week then.